So today we are going to talk about DevSecOps and like how do we use that in security, definitely, and everything related to DevSecOps, its best practices. What is it? Is it a field? Is there any career in it in Pakistan or abroad or anything like that, right? And a little bit introduction about Hassan bhai. He and I have been working in eBricks for I think maybe an year, and then he went ahead to Germany. तो आज की उर्दू वैसे बेसिकली उर्दू में और इंग्लिश मिक्स होगी तो आई वुड जस्ट आस्क क्वेश्चंस टू हिम हसन भाई पास रोल क्या होती है ज़ूम रोल क्या होता है एडब्ल्यूएस एवरीथिंग रिलेटेड टू सिक्योरिटी असेसमेंट टू एडब्ल्यूएस सो ही इज द काइंड गाय हु वुड आंसर दैट ओके सो गेटिंग ऑन टू द रूल्स बिफोर वी स्टार्ट द टॉक दैट वुड बी कि अगर आपको किसी को कोई भी क्वेश्चन है at any time you guys can raise your hand and I would unmute you and you can ask the question और दूसरी चीज़ आप चैट में टाइप कर सकते हैं वो मैं हसन भाई को आगे कन्वे करता हूँ सही तो आई थिंक दैट गुड बीट और अगर आप यूट्यूब पे ये वीडियो देख रहे हैं तो यू कैन ज्वाइन आवर डिस्कॉर्ड चैनल एंड ड्रॉप योर क्वेश्चंस इन क्लाउड सिक्योरिटी चैनल वी हैव अ स्पेसिफिक डेडिकेटेड क्लाउड चैनल टू क्लाउड ओनली राइट सो ओके ओवर टू यू हसन भाई you can take it off.
तो मैं मेरे ख्याल से इंट्रोडक्शन पहले ही उमर ने करवा दिया है मैं हसन हूँ और मैं आज प्रेजेंट करूँगा DevSecOps का टॉपिक शेयर करता हूँ स्क्रीन विजिबल है मेरी उमर
जी हसन भाई या आई कैन सी इट
ओके लेट्स स्टार्ट थोड़ा सा इंट्रोडक्शन सो सॉफ्टवेयर इंजीनियर हूँ मैं बाय एजुकेशन क्लाउड सिक्योरिटी फोकस है मेरा जिसमें आई थिंक 3-4 साल से ऊपर आई थिंक 4+ ईयर्स हो गए जिसमें मैं फोकस जो है वो ज़्यादातर क्लाउड सिक्योरिटी पे रहा है और उसमें भी स्पेसिफिकली AWS पे डिफरेंट जॉब रोल्स में स्टार्टिंग विद eBricks फिर जर्मनी में भी 1-2 जो मेरी लास्ट जॉब थी उनमें भी एंड स्टिल उसमें मैंने डिफरेंट पोजीशंस में काम किया है लेकिन बैकग्राउंड मेरा स्टिल जो है वो सिक्योरिटी एनालिसिस इंजीनियरिंग और इंसिडेंट रिस्पांस ये 3 चीज़ों का मिक्स ही रहा है थ्रू आउट द करियर उसमें मैंने डिफरेंट पोजीशंस में काम किया है DevSecOps इंजीनियर के तौर पे आल्सो फ्रीलांस सिक्योरिटी कंसल्टेंट के तौर पे काफ़ी सारी कंपनीज के साथ काम किया है और अभी मैं जो है वो सिक्योरिटी टीम जो है वो लीड कर रहा हूँ जर्मनी में बर्लिन में कंपनियाँ फिनटेक कंपनियाँ और बाकी उसके लिए आप अगर और देखना चाहते हैं तो देख सकते हैं मेरी वेबसाइट के ऊपर छोटा सा पोर्टफोलियो वेबसाइट है स्टार्ट करते हैं आउटलाइन से तो आउटलाइन जो है वो स्ट्रेट फॉरवर्ड है DevSecOps का टॉपिक काफ़ी हॉट है और काफ़ी जो है वो टर्म काफ़ी आजकल चल रही है मार्केट में तो स्टार्ट में जो है वो DevOps इटसेल्फ से लूँगा क्योंकि मैं खुद भी ये एक मेरे लिए चैलेंज था जब मैंने प्योर सिक्योरिटी एनालिसिस से शिफ्ट किया था एक DevSecOps पोजीशन के अंदर तकरीबन 3 साल पहले जब मैं जर्मनी मूव हुआ तो स्टार्ट मेरे ख्याल से फिर मैं DevOps 101 बेसिकली क्विक गो थ्रू करेंगे कि DevOps है क्या और क्यों ये मेरे लिए एटलीस्ट चैलेंजिंग था और क्या वैसे जनरली सिक्योरिटी टीम्स के लिए क्या challenges हो सकते हैं और just to wrap our heads around it. उसके बाद फिर थोड़ा सा बात करेंगे कैसे सिक्योरिटी जो है वो DevOps में ऐड हुई और उसके क्या क्या एस्पेक्ट्स हैं फिर कुछ 1-2 एग्जाम्पल पाइपलाइन आर्किटेक्चर्स हैं वो भी डिस्कस करेंगे और फिर डायरेक्टली जो है वो हम डेमो के ऊपर जंप करेंगे उसमें यूजुअली व्हाट a DevSecOps engineer has to do in a day-to-day job वो मैं थोड़ा सा दिखाऊंगा उसमें भी कुछ एग्जांपल्स हैं वो इकट्ठे ही गो थ्रू करेंगे और उसके बाद कुछ हैं कि इफ़ यू इम्प्लीमेंट द DevSecOps प्रोग्राम इन योर कंपनी तो उसको आपने कैसे मेजर कैसे करना है कि आप कितना सक्सेसफुली लेके चल रहे हैं उसको और क्या इम्प्रूवमेंट्स हो सकती हैं वो टाइम कैसे करनी है आपने सक्सेस आपने कैसे मेजर करनी है और फिर एंड पे थोड़ा सा जो है वो प्रोफेशन इटसेल्फ के बारे में कि जॉब मार्केट के बारे में थोड़ी सी जो है वो गपशप कर लेंगे तो ये बिगर पिक्चर है स्टार्ट करते हैं DevOps के साथ सो DevOps जो है वो इन इट्स एसेंस एक स्टार्ट अगर इसका देखें तो ये इट्स अराउंड 2008 ये मूवमेंट जो है वो स्टार्ट हुई है way after the agile movement, और in itself it's, अगर आप इसको philosophically देखें या जो इसके बारे में लिखा गया या theoretically, तो it's a combination of practices, of tools and culture basically. गोल इसका क्या है? गोल इसका ये था कि normally agile जो था, that was the in thing. Agile is a way of developing software. In short sprints, there are several methodologies within agile as well. उसमें मैं ज़्यादा डीप नहीं जाऊँगा, लेकिन वो सिर्फ और सिर्फ सॉफ्टवेयर डिलीवरी तक, जहाँ तक फॉर एग्जांपल एक डेवलपर जो है वो कोड से बिल्ड प्रिपेयर करने तक वो चीज़ जो थी वो एजाइल में कवर हो रही थी. बट ऑपरेशंस टीम्स ऑलवेज हैड इश्यूज़ के अब इसे डिप्लॉय कैसे करना है, और आप बार बार अगर जो है वो उसमें चेंजेस कर रहे हैं, उसकी डिपेंडेंसीज आप चेंज कर रहे हैं, उसकी रिक्वायरमेंट्स आप चेंज कर रहे हैं, तो उसके लिए जो ऑपरेशंस को कॉस्ट पे करनी पड़ती है टाइम की, या फॉर एग्जांपल आपने वेब एप्लीकेशन की एक बिल्ड बना ली है, लेकिन उसको आपने जैसे डिप्लॉय करना है किसी भी सर्वर के ऊपर, आपने अगर एक साइलो के अंदर काम किया है डेवलपमेंट टीम ने, तो उसको डिप्लॉय करने के लिए अगर आपकी रिक्वायरमेंट्स सब चेंज हो चुकी हैं एंड यू आर टेलिंग योर ऑपरेशंस टीम नाउ कि भाई ये तो हमें डिप्लॉयड चाहिए, एंड देन इट्स ऑन द ऑप्स टीम टू फिगर आउट. तो ये एक काइंड ऑफ एक साइलोड प्रॉब्लम जो था वो स्लो डिलीवरी कॉज कर रहा था सॉफ्टवेयर की. तो बेसिकली तब ये फिर शुरू हुई डेवऑप्स मूवमेंट, जिसमें फोकस तो था वो ये था कि आप जल्दी से जल्दी अपना जो सॉफ्टवेयर है उसको कस्टमर्स तक डिलीवर कर सकें, जितने क्विकली चेंजेस हो सकें उतने उतना बेसिकली जो है वो इम्प्लीमेंट किया जाए. और हाउ टू डू दिस इज़ टू रिमूव दिस कम्युनिकेशन बैरियर के ऑप्स को सिर्फ एंड पे जाके पता चला कि ऑपरेटिंग सिस्टम की जिस पे वो डिप्लॉय होना था सॉफ्टवेयर उसकी रिक्वायरमेंट्स क्या हैं. सो तो तब ये दिस वाज बेसिकली the trigger of how things started. So generally एक सॉफ्टवेयर डेवलपमेंट एनवायरनमेंट कैसे काम करता है, बिग पिक्चर, उसमें आपकी कंपनी है, फॉर एग्जांपल मेरी कंपनी है, मैं उसमें कोई भी प्रोडक्ट है, लेट्स से कोई ई कॉमर्स वेबसाइट है हमारी. अब वो ई कॉमर्स वेबसाइट जो है वो डेवलप होगी, वो बिल्ड होगी, उसके बाद उसके ऊपर आप QA करेंगे, उसकी डिप्लॉयमेंट करके उसके ऊपर कुछ टेस्ट वगैरह रन करेंगे. उन टेस्ट के बाद आप कहते हैं अच्छा सही है, सब ठीक है, अब इसे डिप्लॉय कर दिया जाए. तो ये यूजुअली वो जो है वो बिल्ड, टेस्ट और रिलीज का जो आपका साइकिल है. तो डेवऑप्स इटसेल्फ जो है वो इसको काफ़ी तेज़ बनाता है. वो कैसे बनाता है वो आगे देख लेते हैं चीज़ों के अंदर. प्रैक्टिसेस फिर आ जाते हैं. ये वो चीज़ें जिन पे जो बेसिकली दैट आर द कोर ऑफ DevOps in practice के एक्चुअल क्या रहा होते हैं, which enable a DevOps environment or a DevOps culture or a setup. उसमें continuous integration से स्टार्ट करते हैं. continuous integration है, continuous delivery है, microservices, infrastructure as code. It's not entirely के ज़रूरी नहीं है everything you have is on microservices. This is the new way of making things even faster, so also included here. Monitoring and logging, infrastructure as code, and collaboration काफ़ी जो है वो key part है इसका, because the whole point is to remove the barriers between the dev and the ops teams. So continuous integration से start करते हैं कि ये क्या है. मैं quickly go through करूँगा, and I'll appreciate अगर questions हैं तो आप साथ ही वो raise करें ताकि बात के लिए ना रहे कुछ. तो कंटिन्यूस इंटीग्रेशन जो है ये एक सॉफ्टवेयर डेवलपमेंट प्रैक्टिस है. बेसिकली आप गिट के ऊपर आप एक किसी भी वर्जन कंट्रोल सिस्टम के ऊपर अपना कोड जो है वो कंटिन्यूसली इंटीग्रेट कर रहे हैं इनटू अ स्पेसिफिक ब्रांच, और फिर उसमें खैर ब्रांचिंग स्ट्रेटजीज आ जाती हैं, उसमें नहीं जाएंगे. लेकिन द पॉइंट इज़ कि जो बिल्ड आप सॉफ्टवेयर की बनाएंगे उसमें डिफरेंट डेवलपर्स की कंट्रीब्यूशन होगी. And how do you actually achieve that is the continuous integration of your code. So there are CI pipelines which basically in the end are building your code on every merge, for example, or whatever your company is doing with that. Then है continuous delivery / continuous deployment. ये interchangeably use होता है, लेकिन there is a small minor difference in there. Continuous delivery is generally just delivering the software continuously, but continuous deployment is there is one specific difference कि अगर आपकी जो deployments हैं to the production are also automated. There is no manual intervention. कि from the point your developer commits the code, it gets deployed to your production without any human intervention, without any manual intervention. So that is a little bit of difference between continuous deployment and continuous delivery. So yeah, code changes, continuous delivery is के code changes को जो है वो continuously आप build करेंगे, test करेंगे और production की में release करने के लिए आप उनको उसको prepare करेंगे. That is delivery. And deployment is, of course, you are actually deploying that piece of code to to your production server. Microservices is design approach है ये to build a single application, लेकिन उसको smaller services या सब smaller pieces में divide करके build करना, and then they can talk to each other using a specific interface, using an API, usually an HTTP based API, just to make things easier. Why? So let's say one development team has 20 sub teams, or the development division itself has 20 teams. Every team is responsible for specific part of the product. In the end, ये पूरी एक e-commerce website है, but quite possible कि एक team जो है वो सिर्फ जो आपका checkout की functionality है उस पर काम कर रही है, दूसरी जो है वो login और registration की जो functionality है उस पर काम कर रही है. Now they want things to be उनके development environments different हो सकते हैं, उनके अपने जो their tooling can also be different. उसमें काफ़ी सारे changes हो सकते हैं. तो वो instead of going for bigger changes, in practice Agile plus DevOps work together, and how they work together is कि आप ना सिर्फ continuously code को जो है वो merge कर रहे हैं, continuously उनको deploy कर रहे हैं, लेकिन एक microservice environment के अंदर specifically आप वो बहुत ही smaller changes कर रहे हैं to smaller pieces of services. अगर उससे कोई downgrade आपकी service होती है या आपकी website होती है या आपकी application, तो वो इफेक्ट जो है वो सिर्फ एक माइक्रो सर्विस तक लिमिटेड रहेगा, वो इफेक्ट बाकियों पे नहीं आएगा. एंड देन इट्स इजियर टू ट्रैक कि व्हाट कॉज्ड द इशू एंड व्हिच सर्विस caused the problem and how do you fix it then and who has to fix it. So these things, there are so many benefits to it, taking just a big picture view. फिर infrastructure as code, again infrastructure as code is I think जो at least DevOps engineer position आप देखेंगे market में, this is what most of them will be doing, at least what I have in my experience जो मैंने देखा, which is कि ठीक है application development के ऊपर आपने agile methodology use करके आप continuously एक process के तहत जो है वो code build कर रहे हैं, push कर रहे हैं, integrate कर रहे हैं, test कर रहे हैं, लेकिन same principles को आप apply करेंगे infrastructure के ऊपर. So the old way of doing things was आपके पास basically servers हैं अपने हैं, या for example cloud पे you launch your server, for example an EC2 instance or some compute instance or GCP or something like that. आप उसे उसमें SSH करते हैं, उसमें जाके फिर अपनी जो भी आपकी web application है उसकी build को deploy करते हैं. That's kind of manual, actually completely manual, even though if you're doing it on cloud. लेकिन with cloud the edge is that this cloud will give you an API. तो AWS for example, आप उसकी API को अगर आप यूज़ कर रहे हैं तो you can write the whole thing in the form of code. Then there are several ways of doing it, वो भी briefly आगे जो है वो discuss करेंगे. Different उसमें so infrastructure provisioning जो है that is going to happen itself as code. उसके benefits भी several हैं, उसके भी benefits उसमें से एक जो है वो auditability है. कोई भी infrastructure create कर रहा है, for example again let's look at the DevOps situation. अगर आपका infrastructure code के अंदर है and for example I'm the DevOps guy and let's say Umar is the dev guy, I'm the ops guy and he's the dev guy. मैं infrastructure code लिख रहा हूँ पुश कर रहा हूँ रिपोजिटरी में एंड he reviews the pull request, तो वो देखेगा कि यार XYZ configurations maybe they are not relevant to me. How, और अभी आपने उसको डिप्लॉय भी नहीं किया इंफ्रास्ट्रक्चर को, एंड बिफोर दैट you were able to review this, audit this. Later let's add also security, for example. Security wants to audit कि हमारा इंफ्रास्ट्रक्चर कैसा, इंफ्रास्ट्रक्चर की configurations जो हैं वो कैसी हैं. For example, let's say, do we have all the ports open? Do we allow traffic from the internet or from only specific services? So इस तरह के checks जो हैं वो, of course आप infrastructure को की configurations को भी देख सकते हैं, लेकिन if you have tight controls over things, then it is easy to just read the code, and the code itself is its own documentation. So ये exactly वही application development की approach को infrastructure के ऊपर apply किया हुआ है, using several frameworks and tools. फिर monitoring पे आ जाते हैं, monitoring and logging. So monitoring and logging again is very crucial for DevOps, because also as part of the DevOps philosophy, it's कि आप blameless रखें environment को. If something fails, it's not the person who failed it, it's the system that failed. आपका जो complete system है उसके अंदर you don't have enough, let's say, you're not doing the gatekeeping enough. आप ने आपके system के अंदर अगर कोई problem introduce हो रही है, then it's not on you, it's not on the person, it's on the system itself. So you always try to improve it. But to do this you always have to monitor for the problems, and for example for performance and for other things. Okay, ठीक है, let's say we deployed this time, we tried a different approach. How did it work for us? क्या हमारी API का response time कुछ थोड़ा सा improve हुआ है, latency improve हुई है, availability पे कोई difference आया है या whatever. तो ये monitoring is part of the DevOps. Collaboration, yeah. So collaboration, as I said, the whole thing is about collaboration actually. In the end, it's about removing those barriers and sharing. So if everyone is looking at the same code, and if you have these practices implemented, that there is tight control over what code actually gets deployed. ये controls, for example, आपके GitHub पे हैं, आपकी जो भी Git की आप use कर रहे हैं service उस पे हैं, everybody reviews it, तो आपकी code की quality is already improving, but also you are collaborating right on the code, right where the code sits, before something goes wrong. So this is like a very preemptive approach, or collaboration, that's why it's very necessary. Or usually ये big picture view है कैसे जो है वो any change, how any change is released in a DevOps environment. Basically the change could itself be to just infrastructure or to the application itself. For example, नया feature release करना है, या for example नया your team discovered a bug, and now you want to push a fix for that bug. So everything is a code change. And how do you do it? You plan, create a build out of it, then your CI/CD pipelines, then you know the whole thing. Again, you monitor it, you operate it, and then you also look for the future, what we can improve. तो इस सब में सिक्योरिटी कहाँ पे आती है? इस पे एक्चुअल टॉपिक पे आते हैं. मेरे ख्याल से मैंने थोड़ा सा पहले से जो है वो जिक्र कर दिया था कि कैसे कहाँ आती है सिक्योरिटी. Same problem. So in reality, or actually in theory, DevOps was supposed to take care of security as well. So when in the DevOps philosophy, if you read, like it says कि आप सॉफ्टवेयर को डिलीवर फास्ट करेंगे, रैपिडली करेंगे, साइलोस को तोड़ेंगे और सिक्योरली करेंगे. सो बट इन रियलिटी इट्स नॉट ऑलवेज द केस. व्हाई? बिकॉज security teams work with their own specific tooling. So 3500 किस्म के vulnerability scanners हैं, 10 किस्म की security monitoring के जो है वो agents हैं, forensics के tools हैं वो भी कोई hundreds में हैं. So everything that security teams usually have, it's a big silo. Security teams are usually a big silo that kind of live in their own. और जब एक room में आप enter होते हैं and you are the security person, you're usually either they think you are weird or you think they are weird. So somehow this silo is a problem, of course, for the company itself. Just because the ops or dev have not worked enough on your tooling or you haven't worked from their angle, so this silo causes the same problems or similar problems जो कि DevOps से पहले थी. सबसे बड़ी जो उसमें problem है, that is speed. For example, security teams, this is also another thing that quite famous कि भाई किसी ने ना सुनी है तो security वालों के पास चले जाओ. So security is always like, nahi, you're introducing a new vulnerability with this new release or this new code that you pushed. We're not allowing it. Now, ये तो एक पे आप कह रहे हैं कि like one off you can say that, twice you can say that, but maybe not 3 times. Especially if the developers don't understand what the hell is happening. So this silo brings cultural problems, and eventually security's goal itself will not be achieved. Goal security का ये है कि software जो आप deliver कर रहे हैं या जो company आपकी itself, it should be secure. So when we talk about software delivery or the infrastructure delivery, security ne, even though they tried to stop it, but they couldn't, because eventually if you are working in a silo, you will end up causing more friction than solving the problems. So breaking the silo was basically another trigger. But as I said, DevOps itself says that security should be a part of the whole process. But since in practice it wasn't, फिर ये DevSecOps की भी एक movement type या एक trend है वो चल गया कि भाई security की जो tooling है, let's add that to the usual CI/CD pipelines, and this way we will be improving transparency. आपको अब जो है वो खाली बस बातें नहीं करनी पड़ेंगी कि यार this is security जो है वो like for example the X vulnerability or Y vulnerability and what is the reason and what will be the impact and so on and so forth. Especially जब आपकी for example for the companies which are actually doing DevOps, जो दिन में शायद 5 या 6 दफ़ा शायद रिलीज डिप्लॉय करते हो, इतनी फ्रीक्वेंट अपडेट्स हैं, या इवन आप एवरीडे भी कर लें, then ये फिर बड़ा क्रूशल हो जाता है कि because for all from the security's perspective, for all you know, every commit or every feature release may have another vulnerability because you have not tested it. So how to remove this, break this cycle? So to break the cycle, you have to get into it. And this is when basically shifting security left is another acronym being used for this. कि security को आप left in the DevOps cycle जो है वो move कर रहे हैं. इस पे आगे देखते हैं अभी what it actually means. So yeah, कैसे इसको achieve करना है? ठीक है, DevSecOps करना है भाई, security को add करना है, but what exactly and how we are going to do these things, breaking the silos and shifting, making security more preemptive than reactive in these companies. So firstly you start with the security as a contributor to the DevOps itself. How do you do that? You try to understand how the usual deployments work from application perspective, from infrastructure perspective, and then you once you have understood कि क्या हो रहा है और हम कैसे software को deploy कर रहे हैं, then only you can try to improve it security wise. Then increase trust and transparency between the 3 units. So operations, dev, and sec, it's basically the same thing. Again, just by adding the tooling to your CI/CD, you may not be doing DevSecOps, because again, अगर आपका culture नहीं है और अगर आपके developers in the end they are demotivated from the side of security, they are not fixing vulnerabilities fast enough, आप जो है वो basically you will not achieve anything. So again, in the end, things boil down to culture, that you try to build up the culture which is collaborative, जहाँ पे ये सब काम इकट्ठे कर सकें. Then integrating the security ideas into DevOps. What this means, for example, So tooling, as you can see, is another point. So tooling, yeah. पहले हम vulnerability, हम पहले like the traditionally आप को बिल्ड मिलती थी, आप उसके ऊपर कुछ स्कैन करते थे या उसको डिप्लॉय करने के बाद उस पर कोई डायनामिक स्कैनिंग करते थे, सम वल्नरेबिलिटी स्कैनर, बट shifting left means you start doing it early as possible, as early in the development life cycle as possible. So any ideas? Also, for example, let's say आप सिर्फ सिक्योरिटी उसकी स्कैनिंग की बात हम नहीं कर रहे अभी कोड की या सिर्फ उसको सिक्योर करने की. You could also be doing compliance as code. You could also be like any security ideas that you have on the table, because now you have cloud, because now you have so many automation options. So aap basically security teams, it's an opportunity for the security teams to reduce their own workload in a sense and make their own lives easier because of this this whole culture and this whole movement. So what does it mean by shifting security left? So usually kaise tickets, for example, if you're sitting on the seat of a developer, so how does it look like? You have Jira or you some ticket management system. You have a backlog जहाँ पे आपने already जो वो tickets create की हुई हैं, like what things we should be working on, what features need to be added, what bugs need to be fixed, and so on and so forth. You, as a developer, you pick up every day, you pick up a ticket and you start working on it. Normally, these tickets are like, for example, they are stories, user stories as well. For example, like user sees this page, he clicks that, this happens, and so on. And you try to implement that in your code. So then, because we're talking about the DevOps, you're going to commit this code into a version control system, Git, for example. Once you commit it, then depending upon how you configured your CI/CD, you may be creating a build out of it on a specific branch. That build gets created. Someone tests it. Maybe there is automation again for the testing as well. And then you deploy it to the production server, and then your team monitors it. So this is the usual flow of things. Let's cut out के अभी इसमें DevOps है या Dev है जो भी है जिसने भी किया, because the same is true for the infrastructure code. The same is true for application code as well. So whatever you do, this is the usual cycle. आपकी pipeline में stages के नाम different हो सकते हैं. Everything can be changed, but anyhow. So when we say shifting security left, what is meant by that is start for this piece of code that this developer just committed, try to scan this for security issues as soon as possible. Try to detect security problems right from when he is, for example, coding. So like in the IDE, there are extensions now for Visual Studio Code या Atom या जो भी आप यूज कर रहे हैं उनके लिए extensions हैं जो कि आप while you are coding they can scan your code for several issues. So static scanning basically, or if you are using vulnerable libraries or packages, so dependency analysis, this can be done while you are doing while the developer is coding. So this is as left as it gets. Or for example, some quite common of an issue ke because it's the world of APIs, you have plenty of credentials. Or आए दिन incidents तरह के आए होते हैं कि some developer committed some credential into the code, and then because they didn't make a pull request or whatever, they just committed directly to the master. The code is already in production. So that's one of the problems. How from the security perspective, you could have, if you had this shifting security left, you could have prevented it. कि अगर commit time पे उसकी machine में he/she had configured some pre-commit hooks. On the commit time, this commit hook runs some kind of secret scanner and doesn't let the person commit, or at least show an error like, hey, you're committing some high entropy stuff, looks like a credential, something like that. So secret scanning, again, that's another part of the DevSecOps tool chain or whatever you call it. अब उसमें deep dive करते हैं. अभी तक, if there are any questions, let's just raise them now, or should I continue?
I think we're good for now. There were some questions, but they were, regarding abbreviations and stuff, so we're good to go.
Okay. Okay, so the same example, जो भी हमने last में देखी है, you get a ticket, you try to develop the feature, you push the code gets deployed, passing through several steps. वो steps कैसे लगते हैं और हर उस step के ऊपर what security can add as part of the DevSecOps or as part of security within the software development lifecycle. So pre-commit, like before you commit stuff, what can you do? Okay, feature ticket create की गई थी. So did anybody threat model that कि ये हम नया feature introduce कर रहे हैं, इसके abuse cases क्या हो सकते हैं, इसका risk क्या हो सकता है if it lands in production without any checks. इसके लिए जो आप packages, इसके लिए जो आप packages या libraries या जो इसके लिए आप technically stack use करना चाह रहे हैं, how mature is that, and so on and so forth. So all those questions that are preemptive, and you start them right from the requirement stage. Of course, you need a security mindset that is thinking of the abuse cases right from the beginning. Then, as I mentioned, IDE security plugins, several of them. You have for infrastructure code, you have for application code, for almost all the modern languages. So that's something. Pre-commit hooks, as I mentioned, and then importantly peer code reviews. So you can always, and this is done sometimes, but yeah, you can always get your code reviewed by your colleagues. Also by this is by the way also at commit time. Like for example, you commit the code, but not to the main branch and not to the master branch of the code of your repository, but for example some feature or development branch, and that will not be merged to the master, and hence won't proceed to deployment unless someone reviews it. And this is the usual way of doing things in these DevOps based companies. Everybody, like in a good DevOps environment, there are no exceptions about this. Everyone's code has to be reviewed, and yeah, then you can be critical on the code, and being critical there then improves the quality of the code itself, of course, and also security issues can be caught this way. Commit time पे static code analysis, you committed the code, for example, you pushed it, इस पे क्या हो सकता है? So let's say you have Sonar Cube or some static code scanner that can run on your code, और वो उसमें जो है दो चीजें, for example, one which is the traditional static scanning, and the second is dependencies analysis or dependency scanning if you're using vulnerable or outdated packages. So that can be caught in the static scanning. Dependency management is exactly that. Container security, yeah, if you're using, for example, Docker images, the same applies to Docker files as well. So because आपके पास एक Docker file है, and then you create an image out of it, and before even you create an image out of it, it can still be scanned for issues. So there are tools, we'll have a quick look on those tools as well. Then acceptance. So acceptance stage में फिर आपके पास आ जाता है कि, like for example, the PR was merged. What now? Usually, so infrastructure as code, cloud infrastructure. Usually, this depends on how you have set up your CI/CD pipelines. Again, sometimes I've seen एक आपके पास pipeline है where जिसमें infrastructure changes, because we are using infrastructure as code. Infrastructure changes भी उसी का part है, application भी उसी का part है. So you commit only in one repository, and depending upon the change, only the relevant jobs will run, for example, and then अगर आपने change जो था, let's say you had a Terraform template, आपने उसमें कोई change किया था, आपने EC2 server का size ज़्यादा किया, or whatever the change was, so that gets deployed. So why in acceptance testing this is mentioned is basically we're looking at from the application angle, and for application to be deployed, there needs to be infrastructure already there, so it can get deployed on that. And then dynamic testing. Dynamic testing is, yeah, for example, run SSLIs, NICTO, some other vulnerability scanner that you have that runs on the build itself. So this is, we're talking, let's say, pre-production, for example, right now. Usually there are multiple environments जिसमें ये testing की जाती है, किसी भी किस्म की dynamic testing. It could be also your QA testing some stuff, your automated jobs that run on basically your HTTP endpoints. So that those dynamic security tests can be part of the pipeline as well. And then security acceptance tests as well. Like, what is the criteria for security? If basically it's a whole lot of automation that you can put on every single stage of your software development lifecycle. Yeah, security smoke tests, secrets management, configuration, and actually you can move around some of these pieces as well. Secrets management is not equal to secret scanning or secrets detection. Right now we're talking about, okay, production may there's this application deployed that needs to talk to, let's say, some AWS services. How does it talk to AWS services? Maybe some credentials that it uses, or for example, like for example, the application needs to use a Docker container. So it will have to pull a Docker image for that. The Docker image lives in a Docker repository, and how do you authenticate with that? The application needs some credentials. So in the end, any kind of credentials, database credentials, for example. So any kind of credentials that your application does need, how you are managing those credentials. Ideally, a secrets management solution. So HashiCorp Vault or some others, secrets manager from AWS, tons of ways and tons of tools to do those things as well. Then we talk about security configurations and the server hardening. Again, this is infrastructure oriented a little bit. So security configurations, again, are we following the security best practices for where the code is getting deployed to? Like it could be as simple as, let's say, do we have the security headers that should always be enabled or the operating system has specific patches or specific baseline configurations that we want to meet, and anything basically that you can put into code. And this is basically where we also call compliance as code. So yeah, this is production, and then we talk about operations. Operations is when the build got deployed. What can you do with it now, or what will be happening from here on, both from ops perspective and from security's perspective. Something went wrong. So an incident could be an attack caused an availability, like a DDoS, degraded your web application, for example, and now you have a availability-based incident. You try to mitigate it, whatever. Then usually these, again, as part of the DevOps principles itself, you don't blame the people. You blame the whole system itself, and you try to improve the system by doing these blameless postmortems after these incidents. Like, what went wrong? How we could have avoided this? How in future we can avoid this, and so on. So usually these postmortems are a very good way of maturing your infrastructure and stop that problem from happening again. Continuous monitoring. This is again both sides: availability monitoring, performance monitoring, security monitoring, and any kind of monitoring. So again, you're monitoring for stuff that, okay, now the software is live. We know that everything went well. Only that's why our software got deployed, but still no static or a dynamic code scanner is going to find business logic flaws, for example. So still things have to be tested. Still things have to be protected. There needs to still be a WAF. There needs to still be a tight perimeter. So yeah, and around that perimeter, your security is monitoring whatever controls you have, whatever you have placed. And then threat intelligence. what kind of attacks you're facing, what are your patterns, are there any TTPs that are well known, and so on. So all the security monitoring thing that is post deployment that you can do with it. Okay. अब इस सारी को summarize करते हैं and we'll try to come to what exactly in an application security pipeline practically that you will see, and then we have some examples as well. जिसको फिर briefly discuss करेंगे. Yeah, SCA. SCA is software component analysis or basically dependency analysis. जैसे कि for example आप Python में आपकी application है and you're using requirements.txt file to manage the dependencies, and within those dependencies you're using a package that has, I don't know, like itself is vulnerable or is dependent upon another package that is vulnerable. So basically is introducing a vulnerability in your code, and you didn't have to deploy the application to find this out. You can do it right from the beginning, starting with an SEA. So basically in your usual DevOps pipeline or a CI/CD pipeline, which deploys this application, you add a new job to it. And before the build is created itself, so in the CI, we're right now talking about the CI pipeline. Before the build itself is created, you look for specific, let's say, you run some tool that is specific to your language. In this case is Python, so we would probably use safety or some commercial like Snake or some other dependency analysis tools. This will run as a job in your pipeline, and this again depends on your maturity of the DevSecOps pipeline. Like, do you want to proceed if there is a medium vulnerability? Do you want to proceed if there is a low vulnerability? Starting in the beginning, you'll probably only be doing, let's say, like really blocking the pipeline or blocking the deployment of that application, let's say for critical or high vulnerabilities, or maybe only critical vulnerabilities. So yeah, these are some of those things that then once you start doing DevSecOps, once you start adding these automated jobs pipeline में, then आपको ये सोचना पड़ता है ये सब considerations के किस हद तक जो है वो restrictive रखनी है security. You cannot just come in there and add some tools randomly and start blocking deployments, because that already will kill the whole point of building the culture, because that will introduce, let's say, friction, and tools can have always false positives. Maybe not SCA tools. Usually they are very accurate, because they're looking for specific versions, finding the CVE for that, and blocking or taking the action or whatever your job describes to do them to do. But simple static scanning can have false positives. Secret scanning also in some cases can have false positives, and so on. Same goes for SAST. So SAST like SonarQube and so on. And DAST definitely has a lot of false positives. So yeah, when we start doing these things as part of the development lifecycle, we have to be very careful that you start small, and gradually you try to improve your tooling. You try to improve the rules that those tools use, ताकि false positives एक हद तक जो है वो यहाँ बिल्कुल reduce हो जाए. And then once you have built enough confidence, then you just let those tools start blocking stuff. That now if it has found medium vulnerability, that it definitely is a medium vulnerability. So once you can say that about your automation, only then you start start blocking these things and blocking vulnerabilities from reaching production. So yeah, what else? So here I'm trying to cover very specific stuff that I have seen happening in a pure in a pipeline, in a DevSecOps pipeline, where you're trying to only protect the application. आपकी application की जो deployment pipeline है, you're only trying to, just it's a lot about hardening. Basically, that's it. It's hardening. It's tons of hardening, vulnerability scanning, and then in a better setup, you will probably have good vulnerability management tool as well. And then these tools, as whenever these jobs run, whenever basically you are deploying, these jobs will be sending those vulnerability data, whatever they get, in a machine readable format, so JSON or XML or something like something else, to this vulnerability management tool. And then you have, in a single place, you have all the vulnerabilities, and your security team can keep an eye or follow up for the fixes or whatever. Yeah, what else can you improve in the whole DevOps pipeline or in the whole CI/CD pipeline? So as we said, सिर्फ applications नहीं है हमारे पास secure करने के लिए. Cloud itself is a problem when it comes to security. If you don't know what you're doing and most of the time you're using the default configurations, you're probably creating new infrastructure security issues without even knowing. So when you have infrastructure as code, जब आपका infrastructure जिस पे आपकी application deploy हो रही है itself is already part of your some repository, apply the same techniques to that as well. Now this I haven't seen, I mean, I have, yeah, in my experience, whenever someone is talking about DevSecOps, most of the people don't talk about this for some reason. Configuration management they talk about, compliance as code they talk about, but somehow infrastructure security is missed, but plenty of other people are also talking about that. So in my opinion, when you're talking about security in the DevOps, cover everything. So if you're doing hardening and you have opportunities to automate stuff to find security issues, use them, use the same things, use the same techniques, but maybe different tools for your infrastructure code as well. Configuration management, इसमें से quickly go through कर लेते हैं. Configuration management is, for example, yeah, you want to have, for every production server, you want to have specific users only rolled out to them. You want those servers to also have specific configurations of, for example, you want to install a security monitoring tool, which has an agent. You want to install some application performance monitoring tool that has another agent. How do you, so you have a baseline of a server. So you create those baselines, like this server should have these 3-4 agents. These tools should have XYZ configurations. Our SSH server configurations should be hardened until this level. So the SSHD configs should look like this. Whatever your whatever the configuration changes you want to make, then there are tools to manage them on scale. So every single server, so if your server was running in an auto-scaling group and there are 100 servers running of the same dish, all of them should be the same. To ensure that and to automate that, yeah, you have configuration management. Sometimes you will probably see some Ansible को शायद आप infrastructure as code maybe देखेंगे, because it has things that it can do. For example, Ansible also has AWS module that you can use to provision your infrastructure as well, but that's not why it was made. So anyhow, then we have compliance as code. Compliance as code is, so configuration management you did, okay, good, but you still want to be sure that we are complying to our XYZ baseline configurations after the deployment. Why? Because let's say you did have Ansible, you deployed your servers with those configurations, but they are still SSH users who can go in there, change something manually on the server. How do you manage that? Then compliance as code kicks in. Maybe you have an automated job that is trying to run a tool like Chef Inspect. So Chef Inspect is, it has some, like, for example, you create a profile in Chef Inspect which says my Ubuntu server should look like this in the baseline configurations. This works using SSH. And you define whatever that configuration looks like as a profile. You run Chef Inspect against your production server. It tells you, okay, आपके 20 चेक्स में से कितनों के ऊपर आपका सर्वर जो है वो पूरा उतर रहा है और कितने कंप्लाइंट हैं, कितने नहीं कंप्लाइंट एंड ऑल दैट स्टफ, but in the form of code, of course. And since it is in the form of code, you can run it in the pipeline as well, and you can generate its output in a machine readable format. That can also be fed to your vulnerability management system, however you want to configure it. Yeah, and then continuous integration and delivery. So CI/CD tools, of course, this is a big part of the whole conversation. So you define your workflows, you define your pipelines. के commit time से लेके remote commit या remote push से लेके deployment तक, what are some of the things or what are the things that you want to do and in which flow. So maybe you want to do secret scanning first and then dependency analysis. So there will be one job for secret scanning, and then there will be another job that runs in this whole pipeline. How do you define this pipeline? There are several tools, Jenkins, GitLab CI, code pipeline, and so on. But then again, there is a security consideration here as well. You can also make mistakes. Like there is also like pipeline itself is a resource in cloud's terms. So you also have to protect the pipeline. And then there are pipeline security stuff as well. For example, different considerations for Jenkins, different for GitLab, and so on. And then there's artifact management. So artifact management is, in a gist, it's what is your release and what is the image. For example, in this case, let's say Docker registry, ECR, JFrog, or then there are so many tools that can do this or would be used to do this. So an artifact is, for example, a specific build that you created that got deployed. How do you version it? How do you keep a track that what is running in my production? So you always do this using, for example, artifact management, different tools, or tagging your images, maybe tagging your branches sometimes with release names and versions and so on. Yeah. So this is now a sample pipeline for application security. As you can see, start करते हैं बिल्कुल raw से. It looks too big, but it's just so many jobs. That's all. So DevSecOps engineer. By the way, this is all using AWS stack, purely AWS stack. That's why you see only AWS services here, and it's not. It's an open source project called DevSecOps Factory. Yeah, so Cloud9 is basically an IDE. You push from an IDE. Code commit is a Git system by AWS. So host your code. You make the commit. Commit goes. Now, what can you do with it, or how some of those jobs or whatever we have discussed so far falls into place is using AWS code build for or whatever thing that can run bash basically. In the end, you start adding these security toolings in there. So Hadolint जो है वो ये Docker linting के लिए Docker files को scan करने के लिए ये tool है. Then there is detect secrets, secret detection के लिए. Then there is Snyk. So Snyk also Snyk does basically dependency analysis. So commercial tool है. Again, there's I think an open version as free version as well. Same goes for Dagda, same goes for Bandit, like whatever you want to. This is all SaaS, by the way. This is all static scanning. Either dependency analysis, the Bandit, for example, is static analysis. Then Trivi is for scanning the images of Docker images, basically. And once these all jobs have run successfully, let's say the job fails at Trivi, it means that the next action probably won't happen. For ECR पे कोई भी जो है वो चीज़ deploy नहीं होगी, image आके push नहीं होगा because the image itself was vulnerable or had problems. So this is how you create these jobs, all of these security tooling, put them in a pipeline in specific stages, however it makes sense. Usually the SaaS ones will be more towards the left, or more when we say towards the left, it's earlier in the pipeline. And that is exactly what shifting security towards left is, detect things as soon as possible. Then the code deploy service is for, it's for deploying the releases or deploying whatever comes. An AWS Fargate is a service to host clusters of containers. So yeah. And then all of these tools, if you can see security findings. So they have security findings. Maybe you want to use Security Hub or some other vulnerability management tool जिसको ये output कर रहे होंगे अपनी जो भी ये findings हैं इनकी. Maybe you have configured the whole pipeline in a way कि ये सब tools चलें लेकिन build को fail ना करें. So that's exactly what I'm saying. You don't start with failing stuff in the pipeline. You always start small and start finding like at least they generate these findings. They put in a central place and then your security team looks at it and tries to improve the automation over time, reduce false positives and so on. And yeah, this is how it works.
Hassan, we have a question. Sorry to interrupt. So it is regarding supply chain attacks. Let's say there was an evil manager of a project, right? And he intendedly let some developer or himself add some, buffer overflow or something like that in the code. So how do we detect that, like in these pipelines, or how do we check our old code for, security issues? How do we do that?
Yeah. So depends. Again, for example, so code curve breach is one of the recent ones. Let's talk about that. That is a similar scenario. Supply chain attack. So let's say, for example, Trivi. Let's take Trivi as ये tool है जो हम जिसका Docker image pull कर रहे थे इस specific stage के अंदर, but we don't manage the image ourselves. हमने Trivi को run करना था अपने image पे. So लेकिन चूंकि हम सारी jobs अपनी code build की jobs को run ही let's say Docker के अंदर कर रहे हैं किसी container में, so पहले it will start with Docker pull Trivi image, and then you run this image and you give it the target. But what if this needs, let's say, credentials or whatever? It's running in our environment, this code, this container, but it was not developed by us. And this is quite common Docker images case ke andar. So this is one of the examples that you are using an image or package created by someone else that got breached, that company got breached, let's say, Trivi, for example, in this case, someone made changes to that Docker image and you are just pulling the image every time this pipeline runs without checking whatever. Yeah, whatever this container or the environment where it ran had access to will probably be out to the owner of that, whoever pawned that first company. How do you stop it? So artifact management, or again, you check the integrity. You always match the integrity of the hashes of the images. If you're not, like for example, आपने Trivi से image pull किया, and you usually these companies have like, okay, जो हमारा latest image है उसका जो tested है, जो secure tested image है हमारा उसकी ये hash है. So when you pull that, you always try to match the hash. So this is one of those ways, but it really depends on exactly what the scenario, what the attack is, yeah, you take a look at that and then deal with these issues.
All right. Okay. So what about old code, right? Let's say there was some repository or some tool or some feature which was left by some department, right? And then the manager or the developer has left. So like, how do we scan that? Do we use the same tools? Do we just directly add it to our code? Like, what do we do in that case?
Yeah, that's so it depends. So again, for example, all of these tools, the SaaS tools especially, like right now we're talking about scanning the code, so मैं उसी पे रहूँगा, dynamic पे नहीं जाते, static पे रहते हैं. So static is, it's not necessary कि वो उस diff को scan कर रहा होगा सिर्फ. Some tools work in this way कि आप, for example, the pull request के अंदर जो change हुआ है सिर्फ चीज उसी को आप test करो, depends. But not every tool work like that. Most of the tools will scan the whole thing by default anyway, so it will be caught. अगर नहीं है, लेट्स से अगर आपकी जो टूलिंग है वो इस चीज़ को सपोर्ट नहीं कर रही, तो देन रन अ मैनुअल स्कैन, सिंपल.
All right. Okay. Thank you.
Okay, let's move. So this was an application security pipeline. We're more focused mainly on the jobs or the tooling that will help secure the build of the software that we are deploying itself. Now we go to the infrastructure security. So again, the assumption is that we're using infrastructure as code. In this case, this is CloudFormation. And there are several static scanners for CloudFormation. तो हम इंफ्रास्ट्रक्चर पाइपलाइन जो भी हमारी पाइपलाइन इस इंफ्रास्ट्रक्चर को डिप्लॉय करती है जाके, जो एक इन द एंड इट्स कॉल्ड अ क्लाउड फॉर्मेशन स्टैक, उसको द सेम अप्रोच वी विल अप्लाई इट हियर. सो IDE से आपने कोड कमिट में कुछ पुश किया, which will be a cloud formation template or set of templates. Then we have several different static scanners, as I said. CFN Python lint, now it is called CFN lint. Python based tool है जो कि cloud formation को scan करता है security issues के लिए. You can run it in a CLI, and basically whatever you can run in a CLI, you can run in this code build jobs as well. These are bash things. So same goes, detect secrets, because even CloudFormation stacks have parameters. Someone past being lazy just committed something over there as well, quite possible. Then you add CFRipper. Again, it's another CLI tool, scans CloudFormation for security issues. CFNNAG is a similar one. Checkov is a similar one. So it's like you put in what you have, you try to find security issues in there and take decisions based upon, like for example, in from the pipeline perspective, I know it's not too much clear in the diagram, but anyway, we could have only one job and we call it SAST, for example, and run all of the tools in SAST. Even if one job fails, we fail the whole stage, and the production and the deployment does not proceed. So this is one of the same approaches that we applied just to infrastructure code. You could do the same thing for Terraform. You could do the same thing with whatever you have. Let's move to a quick demo if there are no questions.
I do have a question, if you don't mind. So we talked about credentials, being committed by mistake into the code, and let's say the build also got deployed to production. How do we actually go passwordless? Let's talk about AWS. In case of AWS, how do we do that, right? I do not want to use any credentials. How do we do that?
Okay, so tooling. First आपको देखना पड़ेगा कि आपकी tooling क्या है, ठीक है? अगर AWS के इसी केस में बात करते हैं, अगर आप ये सारा कुछ कर रहे हैं और आपने ये सारा कुछ करना है सिर्फ AWS के अंदर रहते हुए, then you are just using, the assumption is you're using pure native AWS services, because then you are able to leverage roles, not credentials. So at least on AWS API level, जो भी आपकी resource interactions थी, that those will be taken care of by the associated role. And now this, obviously, you'll find resources that don't support roles. So in this case, that's probably a different story. Lekin generally, this should be, I think, done quite easily in this stack, if you can see. But if you want to go with a mixture of things, so like you have GitHub, and then you have something deployed on GCP, something else deployed on AWS or elsewhere, whatever. And if there is authentication in there, this will always be the case. आपको authenticate करना पड़ेगा. When we say going totally credential less or password less, so if you're doing your secret management very well, अगर आप for example HashiCorp Vault use कर रहे हैं, that allows you, maybe there are other secret managers as well that allow the same approach. They allow you कि आपका जो actual secret है, that always stays with them, but they generate a temporary credential for you. In the end, it's again a credential. So, but the exposure is quite limited because it's going to expire. So that's another approach that you can take. Secondly, there are some ways as well, like using Vault, that you don't have to store that thing. It will only be in the memory of the production server or container, whatever. लेकिन on disk storage नहीं होगा. So yeah, you can avoid on disk storage. But of course, then it depends on your tooling. You have to probably retool, or maybe your current tooling allows that or not, and depends on what you have.
So here, thank you, Hassan. We can continue.
Okay. Okay. All right. So DevSecOps. So start करते हैं एक छोटी सी एग्जांपल के साथ. So all the jobs that we saw over there, उनमें से एक छोटी सी जॉब जो है वो मैंने इस पे लिखी है आज, जो हम ट्राई करते हैं कि देखते हैं कि what is the usual approach, or yeah, a DevSecOps person would take. So there is this one project जो CFN Goat, ये Bridge Crew एक company है, they have created this vulnerable CloudFormation templates जिनको हम एक जॉब के थ्रू स्कैन करेंगे और वो देखते हैं कि how does this thing work, and then we'll also take a look at the pipeline. So so yeah, CloudFormation 101 quick. These are YAML templates where you define some parameters, and then we're creating some resources based. The parameters are basically input values, and then we're creating some resources in the resource section, some VPC, some route table, blah blah blah, whatever. I'm not going to deploy the stack because that costs, but we're only going to take the static scanning examples here. So, okay, let's go back to the CLI and देखते हैं कि कैसे चलाते हैं इसको. As you can see, we have this CFN board. I added this as a separate module here. And now I will just try to run, yeah, by the way, I already have the Docker image for this checkoff, so I'm going to use that for this period. So device, so okay. So this is one-time run. So checkoff tool है जो हम चला रहे हैं. You can see it here, for example. That was fast. Yeah, this is the image name जो हम चला रहे हैं. And what it does, if you can see already, passed checks 0, failed checks 2, and yeah, it failed some checks and is telling us why it failed. Ensure Lambda function is configured for dead letter queue. IAM policies do not allow write access, blah blah blah. Data doesn't, yeah, IAM policies does not allow data exfiltration, so we have probably a very loose IAM policy, as we can see. Yeah, the principle, the resource is static. So अभी code हमने deploy नहीं किया, अभी हमने कुछ नहीं किया, so we just ran this checkoff and it generated already some problems for us. What else we can do with this? I think we can also do something like this. And I will explain why. So now we have JSON output. Two things to quickly see here. So that output was the first CLI output was useful if I'm doing a manual analysis and quickly checking if my CloudFormation code is vulnerable myself, sitting on my laptop. But that is not good for a CI/CD pipeline. Why? Because there you have to parse the data. आपको जो उसकी CLI output है, that is harder to parse. So instead of using that, I just used a flag to generate JSON output, because this is easier for me to parse. And why would I want to even parse this? जैसे कि diagram में था, I may wanna get all these findings and send them in a central place. So that's why I would like to parse them. Or maybe make a decision based upon the job, or based upon how many of them are failing, and so on and so forth. But another way to make that decision is also just checking the error code, because जैसे मैंने mention किया, most of these tools are defining your jobs in bash scripts. So आप अगर error code आपका 0 है, it means the job ran successfully. वो उस केस में होता कि अगर checkoff को कुछ नहीं मिला था, checkoff is like, yeah, all clean, सारी good practices you're following stuff, so I don't have anything. In that case, the exit code would be 0, so probably the job could just proceed. But in this case, it's 1, which means yes, don't proceed. Now, अब आपके CI/CD tool पे ये depend करेगा how you take care of this problem, and how, if you want to proceed or not, if there is an exit code, or if you totally ignore it, because, well, you're very in the beginning of your DevSecOps maturity stage. Okay, so this is something that I had already in place. अब कुछ जो है वो different करते हैं. Okay, yeah, let's quickly check also. Yeah, so I have this very quick check of job. अभी मैंने किया है ये खुद अपने पास. But what if I want to also do this? Yeah, in a pipeline, or basically, like, for example, GitHub Actions is one of those ways to create those jobs in an automated fashion. This is a test job, so nothing, just like some running echo statements, so just printing stuff, but this is actually the job. Let's quickly take a look first, and okay, directly chalte hain, isko play karte hain, and then we see what is happening here. So, or directly to actions. This is the last commit, so you can see it ran. Let's just rerun anyway. So let's quickly take a look. This is the test job, and this is the checkout job. See? So test job is just print, and that's why it's successful. Fine. Go to checkoff. Now we try to understand what is happening here. So GitHub Actions is running whatever I defined in that small job section on in a specific environment on its own. And what I am doing in there in the code is मैं पूरे का पूरा खुद define नहीं कर रहा कि GitHub Action क्या करेगा. Instead, I am referencing another repository, और उस repository से मैं फिर जो है वो actually this one. This is for the checking out. So like within, let's say GitHub Actions is running this whole job in a container. So checkout repo means basically checkout करें इस project की इस main branch के ऊपर. If you can see, यहाँ पे हम main branch use कर रहे होंगे. Yeah, because it's a newly created repository. Then we go to the checkoff. Yeah, then the other one is the checkoff action. It's the same actions in one job, multiple actions in one job. Sorry. नाम दे दिया उसको, और उसको कह दिया कि it uses bridge crew / checkoff - x action and master. Now quickly देखते हैं कि ये क्या है. Bridge crew. Yeah, this is the one. So as you can see, it already tells us that this action, because this is the actual code for the action itself. We are just referencing it and passing it some quick configurations, and then it just works. Let's quickly go through the configurations. Yeah, we can actually go through the job run. So what happened? Okay. So this is actually the command. So these are the environment details. ये उस code से आ रही हैं जो हमने reference किया, and then in the end it runs checkout -d in a specific repository which we told it to. वो भी हम देखते हैं quickly कि कैसे. And we have specified कि मैं जिस चीज़ को टेस्ट करना चाह रहा हूँ, that is CloudFormation, because checkout works with CloudFormation, with Terraform, and I think some others as well. So yeah, and in the end it just says this job status is success. Okay, so हमने यहाँ पे basically we didn't do too much. For example, here we see run name uses run blah blah blah, but here it's just it uses, and then with this configuration we are going to run it, and then we just run an empty print statement that says the job was successful. And of course we can configure this differently, and now this is exactly what we are going to do. So we ran it for CFN code, or Bridge Crew also has more examples for us. Let's quickly take a look. Yeah, CFN code is CloudFormation code. अब हम same repeat करेंगे Terra code से, लेकिन from the beginning. So I copy this. Go here. Okay. So add. This time it should be Terra code. All right, let's see क्या change हुआ हमारे पास. So yeah, git modules itself, and we have a Terra code directory here. Let's just commit update so yeah, my system is obviously configured to work with my repository. And now see देखते हैं कि क्या हुआ यहाँ पे repository. So now there is a new folder. जैसे कि पहले CFN code था. Let's quickly refresh this. 28 seconds ago. So we have a new submodule. Okay. अब क्या करें इसके साथ? वापस चलते हैं. अब इस submodule के ऊपर हम पहले एक दफ़ा मैन्युअली चलाएंगे अपने सिस्टम से, because we have now the directory. Let's go directly to this. So we have Terra code now. All the nice Terraform code is here with AWS, with Azure, GCP, blah blah blah. And we will run now. Let's quickly check if we're setting everything correctly. So Docker run volume this my dash repos, just because playground Terra code. Yeah, you have it. Okay, and then slash Terra code में हम उसे mount कर रहे हैं, and check out my directory slash Terra code. Okay, let's see. Okay, so again, problems. Secrets, problems, you can see AWS credentials commit हुए हैं, secret key, administrator passwords, and so on and so forth. So check out checks for a lot of things. Secret scan, Docker file scan, what else? Yeah, AWS infrastructure based scans. So like one tool for tons of things. And it is telling us for all the misconfigurations, like what exactly is happening. The same thing we can then do like -o JSON, and you know, this will give us a JSON output for this. So in essence, again हमने fail किया basically. Here you see this thing is ref, so macro. Yeah, so one exit code. Why? Because there are vulnerabilities. अब इसको करते हैं कोशिश डालने की अपने वर्कफ्लो के अंदर, या अपनी जो पाइपलाइन हमने क्रिएट कर रहे हैं उसमें देखते हैं कैसे डालना है इसको. या सो काइंड ऑफ द सेम, सिर्फ एक चीज़ हम चेंज कर रहे हैं. Yeah. Now again, see, we have an option. We can create another job or another run statement within the same job. So yeah, we can. I will create a new job. This time we call it checkout dash Terra code, and we change the first job to CFN code. So what is going to change? The directory that we need to scan. The name is Terra code. What else? Still the same branch, still the same action that we want to reference. Maybe we can see what quite true does. And CloudFormation, it's definitely not. So they have already told CloudFormation all. Let's go with all, because this time it has tons of things. So I want to see what happens with that. And output format is still JSON. And this we don't need. Let's review. Okay, let's just commit and see क्या होता है. So back to it. So with every thing, every git push that I do, the jobs start to run. Now this time there are 3, as we predicted or as we expected. Yeah, next thing. Also, is you can see now we can track, like with this approach that we are doing, हम exactly track कर सकते हैं कि which commit or which change, in other sense, was deployed, for example, and refers to which commit, and then you can also see the code. So that's basically with every change. Let's say that there was an incident, and now we are trying to see कि यार ये incident कितने बजे है. What is the last? Let's go to the last commit. Let's go to the start, or let's try to find out when this incident, when the problem that caused the incident appeared first in production. आप उस time के around पे देखते हैं कि कौन सी commits हैं, and then you try to track down things like that. Okay, so it's still running. Oh, we're still calling the same things, checkout dash action. Yeah, the name. Anyway. Okay, all of them have run. Yeah. Problem. CLI. I need CLI. I don't need JSON anymore. Let's try to run it again. Same, yeah. Okay, nice. So check out action. Okay, so please do that, blah. And yeah, so this is like one of the, like how the pipelines look like. For example, most of the time the CI/CD tools that you are going to face if you work in such a job are going to be using YAML. But there are others as well, like Jenkins uses its own syntax, Groovy files. GitHub Actions, GitLab is YAML based, so it's very straightforward, clean to like however the code looks like is going to be almost similar that you would see the visual view of things. So this was just a very quick example of how we just ran a SAST basically, but on the infrastructure code, and we generated something out of it, and the jobs were successful and so on. But this was a very short example. Let's move on to another one. Now we have something else. We have this time it's that one was infrastructure code. Again, here as well, I'm not doing an actual deployment. This is still SAST jobs, but I have the code. I will walk through the code itself. लेकिन जो jobs हम actually run करेंगे वो कुछ मैंने comment out किए हैं. जो run करेंगे they are only going to be some sort of SAST, some sort of static scanning. So अब हम use करेंगे GitLab CI. Or I'm more familiar with GitLab CI syntax and code pipeline than GitHub Actions. So this is, yeah, in this case, मैं use कर रहा हूँ Django NV. Django NV is kind of like intentionally vulnerable Django application. So in Python, अब इसके ऊपर जब हम देखते हैं कि इसका like how do we do those things that we talked about in Django and with a Python-based setup. So we go here. So जैसे हमने देखा GitHub has a different way, like you create that directory जहाँ पे workflow create करते हैं, and then you have a YAML file in there. In this case, we have the YAML file in the root. This is GitLab's way of doing things, and this. Let's walk through quickly through the syntax first, और फिर देखते हैं कि job कैसी, how the job looks like. So starts with image docker :latest. So we're saying कि the pipeline itself or the jobs का जो environment है, jobs के लिए run करने के लिए, that should be using the latest docker image, and the services, or basically again the jobs, will run as containers. Each of these services will run as container within a container. So it's a Docker in Docker approach that we're going to use here. अच्छा, अब यहाँ पे if you can see मैंने सिर्फ 3-4 यहाँ पे stages रखी हुई हैं. We can have as many as we want. This entirely depends on your tooling. Entirely depends on what you are trying to do, what you are playing with. So pipelines, and in the diagrams on internet you will see there are so many different ways. Stages के नाम देने का तरीका different है. Stages को उनके अंदर jobs define करने का. Someone would put I don't know secrets in secret scanning in, let's say, a SAST stage, or maybe in the build stage, or however you want to name it. But anyhow, just to keep things coherent and simple, मैं सिर्फ security की jobs हैं इसके अंदर. There are no actual build jobs or that are building the code or deploying and all that stuff. That is not happening here. And most of the time, not exactly in this one, but most of the time I'm trying to use something Docker based. So like within Docker, for example, this thing, the whole job runs in Docker, but pulls another Docker image and then runs that within the main container. The main container comes from here. अब इसमें से quickly go through करते हैं. So the stage name is SCA, जैसे हमने देखा software component analysis. जिधर हम software component analysis करेंगे या dependency scanning करेंगे. So Django application, we have both front end and back end. Front end will be some JavaScript. Back end में हमारे पास है वो it's Python. So दोनों के लिए different static scanning के tools हैं. यहाँ पे हम retire.js use कर रहे हैं for the JS, and this part is for safety. So safety, safety is a Python based static dependency scanning tool. Then we have static scanning. Static scanning की जैसे आप देखें इसकी stage के अंदर both of them have the stage :SAST, but the job itself is named as secret scanning, or in this case SAST. We can call it something different as well, not a problem. But the point is, this always depends. That's what I'm trying to say. You may be running secret scanning first, even before SCA, blah, blah, blah. That depends on how you do it. यहाँ पे हम क्या कर रहे हैं? यहाँ पे I am using TruffleHog. TruffleHog is the secret scanning tool, secret detection tool that runs on your commits, your recent commits, and sees if there was something committed to your code, and yeah, then gives you output if it finds any secrets. Okay. Docker. Yeah, let's go through the syntax one by one very quickly. So the first stage is going to use a node image, because to install retire we need to have npm, and that is available in the node image. Then for retire itself, once we install it, we run it, retire -- output format JSON. Again, you want things to be readable, machine readable, and some output path, blah, blah, blah. And then you say, this is important, which is allow _ failure. So if the job fails, do you want to move ahead, or do you want to say, hey, the pipeline should fail if this job fails? So let's say we set it to true. We'll see how things go from there. So now we're saying basically, okay, if it fails, fine. Yeah, let it fail. But maybe in some one of these we can set it to false and then see the behavior. So that was very quick. And then artifacts. So artifacts is basically any file that was generated. For example, here we, as an output of the retired.js, we generated this JSON file. And now we are telling GitLab CI that, hey, this is one of those artifacts. Isko upload kar lo apne paas. I may need it at a later time. When basically tells GitLab CI when the job should run. We can have some conditions here, but in this case, this is a very straightforward pipeline. So it's when it's always run this job. Yeah, same stuff here. I missed one thing. Yeah, so this basically, if you see, the script tags are what they are doing is just running bash commands, but like as simple as that. Is nothing too big here. Here we have three different ways. Or the before, I'm using before script because yeah, like I could have run all these commands again in the same script tags as well, but depends on you. Before script, it pulls a Docker image, then runs that image, outputs that to results.json, and once it has used it, removes the image. Why? All of these things are going to be happening on a compute instance in an actual environment, in a production environment. And what you're doing is you're just continuously pulling so many images that, yeah, they are going to be stored on the disk. So yeah, clean them up once the job is done. Same thing here. We put the artifacts, same story, but different tools ahead as well. So SaaS में हम bandit use कर रहे हैं. Then, as I said, there's also, I have this code for dynamic testing. In there, I'm running, for example, Nikto, SSL scan, Nmap, Zap baseline scan, whatever we want to do. But in this case, I would have used, I would have needed a deployed application on a production server that I don't have, and that's why I just, yeah, commented out the whole thing. And in the end, we have this hardening job, infrastructure hardening. So here we're just trying to run basically Ansible so Ansible with some DevSecOps hardening. I will briefly touch this as well here. Actually, this is the better one. Yeah. So DevSec hardening framework is exactly what it says. It's for, yeah, you can use the tooling to harden your infrastructure. How? Using combination of Ansible. You can also use Chef, Puppet, blah blah blah, whatever you want. But this project defines some baselines, some hardening baselines. So, for example, Ansible collection hardening. We go here, or the DevSec project itself, and we see it has Windows batch baseline, Linux baseline, Chef SSH hardening, Nginx, and so many things, so many ways. Like there are already baselines created for whatever you're using probably in this repository, and then you can just start using them. And that is exactly what we are doing in this job. Where is that? The code is, yeah. So some SSH configuration that we need obviously to make Ansible work, because Ansible uses SSH. So यहाँ पे हम क्या कर रहे हैं, यहाँ पे हम Ansible Galaxy को यूज करके इस DevSec OS hardening को मॉड्यूल को इंस्टॉल कर रहे हैं। उसके बाद हम इसको एक इन्वेंट्री फाइल दे रहे हैं कि इस इन्वेंट्री के अगेंस्ट आपने रन करना है। क्या रन करना है? एक hardening.yml फाइल है that you cannot see here because this is I just committed it today. Artifacts, usually, of course, when I am trying to reference this file, that needs to be accessible within the container, because this whole job is going to be running in a container. And how do you make that file accessible? Of course, you have to, you have to make that file part of the project, and then probably here आप जो है उसको change directory into that specific where that file is, or if it's in the root, fine, then you just reference the file and so on and so forth. So yeah, these are some of the things. We could also have had some inspect profile. जो यहाँ पे एक और job हो सकती थी. I mentioned that to inspect compliance as code. So before we run the OS hardening job, we could have run that inspect job that first checks कि क्या मुझे इसको harden करने की server को ज़रूरत भी है या नहीं. So if it already complies to my baselines, then yeah, we probably wouldn't run OS hardening. And then you can create the between these two jobs, you can create a relation like this runs only when the first one is failed, but that job, if it fails, it doesn't still fail the pipeline because it's fine. So something like that. Yeah, we made a change. Let's try to see the pipeline itself and visualize things here too. And create update. Now we go to, yeah, should have triggered a pipeline. So because we had commented out the stages, we can only see the 2 stages that it can find some jobs in. Although in the code I had defined 4 stages, but these 2 stages don't have any job as part of that. So having an empty stage does not make any sense. That's why GitLab was smart enough to just skip it. So let's see what is happening here. Okay, this one finished. Let's see. Let's try to break it down very quickly. Yeah, so preparing the, yeah, as I said, sub jobs हैं वो Docker के अंदर run कर रही हैं, so it first tries to create that environment. Yeah, using Docker executor, fine. Preparing the environment, getting source from the Git repository. So here it basically gets that code. Step script, okay. And here, what is happening? So it's job के अंदर, this is the SCA-frontend. What were we doing here? We were installing, yeah, these 3 commands. We were running these 3 commands in a node image. Let's go back. npm install, sure. npm install minus g retire, sure. And then it runs retire JSON da 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 da. But if you see, we have like, yeah. So we were only trying to find high severity. So these are the flags that we passed. Maybe it's intentional in some cases. As I said, you don't want to fail in the start. And even then, if it finds, we are still explicitly telling it to fail with exit code 0, which is successful. And hence, GitLab thinks that, yeah, the job succeeded. But let's see. And let's see the JSON file. What does the JSON file actually say? Oh, let's try it quickly. Yeah, so yeah, it did find issues. Medium. Yeah, maybe that's why. So it did find issues, but because of the flags, the job was successful, and we let it go. Let's see the other jobs. Okay, those are failing. Back to the pipeline to view things. What is happening? So front end successful है, back end को देखते हैं. Back end में हम again dependency analysis है, so हम safety run कर रहे हैं. Pulls an image, runs that image, puts the file in OAST results, and then we remove the image. No files to upload, no matching file, whatever. Okay, that here it's failing for the different reasons. It's exit code 2, so probably some error. Yeah, and then in a real world, it would have failed the, I mean, if we had configured it to fail the pipeline, this is probably a syntax error, would fail the pipeline. Now we go to the pipeline, some other jobs. Secret scanning, let's see how we go. Same problem. Okay, so no such file or directory, or the argument is wrong, or blah, 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 whatever. And incest. So yeah, that's in a gist the idea. I'm not going to troubleshoot it right now. मेरे ख्याल से हम पहले 2 घंटे ले चुके हैं. But that's in a gist, that's how the pipeline will look like. In reality, it will have different stages like build and then testing, whatever. And then within those pipelines, you just go ahead and add your own jobs or tasks or whatever your tool calls it. And then you run them and analyze, hopefully automatically, if things are machine readable. Yeah, and then based upon that, you also make the decision if you want your pipeline to succeed or fail. So in this case, we see the pipeline passed, but there is this exclamation mark. Why? Let's see the reason for that. Because we have set allow failure to true in all of them. So we're saying that even if we have found vulnerabilities, just let it go. The pipeline should not be effective. That's what we're trying to do. Yeah, that's actually it. Did I have something else? Oh, yeah. Let's continue to measuring success. So the demo is over. Any questions in the demo, or before I move to this maturity model?
Yep. Okay. So I don't see questions from the chat, but I do have one. How do we actually share files between the jobs, right? I don't see any option to.
You can pass the files. Again, depends on what tool you are using and what syntax will exactly be to pass the file. But yeah, you can pass the artifacts. That's why you store the artifacts. That's the point.
Okay. All right. Okay. It's kind of makes sense. So what happens? I'm going a little bit out of context. What happens when you have multiple runners, right? And then we want to share files between them.
Multiple runners.
Yeah.
Yeah. Again, in this case, what you will have to do, let's go back to the code. So runner का context जो है वो execution environment का सही है. लेकिन when we specify कि artifacts path is this, whatever runner ran first will upload this file. Right? This is the producer. वो जो upload है वो GitLab server पे. It's not gonna stay with the runner because runner is going to be, ideally you should be cleaning up the runners because you don't cache to collect over there. ठीक है? So the file will be uploaded to artifacts, and then in this terminology you always call them artifact, whatever the file you are creating. Be it code pipeline, be it here. So in this case, what you will do is in the next job you will make a dependency on the previous job. कि previous job पे dependency है, जब तक वो complete नहीं होती और उसका artifact नहीं create होता, I want to use that artifact as an input for the next job. Okay. So, but in that case, it's living somewhere. So yeah, you can, and you can also do multiple things. I mean, let's say your CI/CD tool. I think every tool does allow that, but if some tool does not, then you just upload it somewhere because you want it. So use a bucket, use something else.
Okay, thank you.
Yeah. Any other questions?
No, I don't see any from the chat about now. We can continue.
Good. Okay, so let's move forward. We have done all the magic of DevSecOps, and we have created various security hardening and vulnerability. So in essence, if you see here, what we're trying to do is automated hardening or automated vulnerability management. That's at least what I see so far. But in reality, at least like if you want to be so ideal, and if you want to say like the philosophically DevOps includes security and whatever, and DevSecOps is like bringing security close to DevOps, fine, then you can also apply the same thing for post-production. So post-production, what can be automated? Post-production response can be automated in certain cases. Like for example, on AWS, whenever X event happens, an X event can be someone made a change to a production security group. A production security group is any security group that is attached to your clusters in production, anything in your compute instances, EC2, ECS, blah, blah, blah. So someone makes a change, go and revert the change immediately and generate an alert. This is not like rocket science to do it. And yeah, security could have its own pipeline that is not deploying anything except these automated actions. So it could be a Lambda function, for example. In this case, it's not, you're still creating software, sure. It's not your main application of the company, which is your product, whatever. लेकिन आप क्या कर रहे हैं कि आप अपना, you are applying the same principles, and you are now producer of software, which makes your life easy, which makes governance easy. So you can also be running compliance as code in automated fashion, like cron jobs. What else? As I said, response actions, some monitoring stuff where you're not taking response, but you're still you want to monitor specific actions. So yeah, anything post-production that you see. So cloud basically gives you tons of opportunities. Use them and do as much automation as possible. So yeah. Now, once we have all these shiny things, तो कैसे measure करें कि हम जो है वो हमारा DevSecOps कितना mature है? So for DevOps maturity, Google has a very nice tool where you can basically, I don't remember the tool, you can actually Google. You can Google what the Google tool is for DevOps, measuring success for DevOps. It's basically you answer a few questions कि आप कितनी releases per day deploy करते हैं, आपकी frequency of change कितनी है, आपके number of incidents की percentage कितनी है, and blah blah blah. And in the end you get how mature your DevOps system is. Now the same thing with DevSecOps, but it's a little different, and there is no calculator that I could found to measure except this big project of DevSecOps maturity model maintained by OWASP. So OWASP DSOM. Yeah, feel free to go through it. I will quickly go through all of these, some of these. So for example, build or deployment time पे आपके पास level 1 maturity के अंदर क्या क्या चीजें होनी चाहिए. So this kind of defines like most of the time in the level 1 maturity, if you can like quickly go through all of these, it's have a process in place, have a defined process in place, which will be followed. और उस process के तहत ही आपकी सारी DevOps pipeline जाना it should look like. Now in different stages, let's say in the build stages, you have, for example, have continuous integration. That's okay. Well, pretty basic. Defined deployment process, how the deployment and who can do these deployments. For example, only master branch should be able to deploy to production. Only staging should be able to deploy to staging. Yeah, things like that. So patch management, patch policy is defined, automated pull requests for patches. So this is like the way of measuring how many of these you have achieved, and eventually when you have achieved all of them, you know, your maturity level 4. Generally for level 1 and level 2, the basic thing is basically you don't go ahead and start failing your builds. You don't go ahead and start failing your pipelines. That's, I think, the gist of this whole thing. There may be some more things that I'm missing out, but yeah, that's at least the summary. So yeah, this is a cool project that you should, I think, if you're interested in this, you should definitely check out. And what else we have in this? Yeah, on the job market. So last thing, okay, DevSecOps engineer ki position, how it looks like. I don't know. In Pakistan, I'm still out of the market for 3 years. Like in EU, I have seen these positions for the past 3 years that I have been here. There are positions in the market. Basic skill set unka ye samne aapke platform. Basically, you need to be able to code, at least in for automation, Python, Bash, sometimes Go as well, because now Kubernetes in ho raha hai, so it's written in Go, and then yeah, Go is also getting in, and you need to be able to develop these pipelines in, I think, 1 also is good enough. Usually it always depends aapki company kya stack use kar rahi hai and the job position, but usually since most of them are using YAML, so you'll be fine if you just understand one. Git, sure, Git is crucial most, and I think for security people coming from pure operations background and haven't done any dev, this is kind of missing. I wasn't using it quite often. Before I did my first DevSecOps job. And also infrastructure as code, Ansible, CloudFormation, Terraform, Docker. These are the things that your DevSecOps guy needs to know, and what he will be doing that we talked about, putting security stuff, automation stuff into the code and making it part of your daily life. How it helps. जो हमने यहाँ पे pipeline में जो हमने output देखी थी, I'm not the security people are not the only ones looking at this pipeline. Everybody is looking at this pipeline. So it increases transparency. If something fails, people are looking. If something passes, people are looking. So there are both aspects to that. And who is watching? DevOps and Sec. So like all the tech divisions or all the tech teams are watching. So yeah, this kind of improves the transparency and then speed of fixing things, creating that atmosphere in the company. Yeah, that's pretty much it. And yeah, if there are any questions, let's have them now, or yeah, otherwise in the end as well, you guys can reach out anytime in the cloud security channel on Discord.
Okay, so the last question would be, I don't see again from the chat, that would be, what are the resources? Let's say if I'm a beginner, right? I am. So how do I get started? And as a DevSecOps guy, where do I learn how to create these pipelines? You know, their syntax and everything. What are the resources?
Yeah. There is, I think, DevSecOps.org. So yeah, DevSecOps.org is one of the great places. If you want to get really hands-on, I would definitely recommend you to check out this project, AWS DevSecOps Factory. But this is again very specific to AWS. This is one of those a couple of architectures that I presented are from here. This is the source. This is a good project to start with. I mean, just start something, for example, this. Start implementing it in whatever your choice is. Don't look for only AWS services. So go for GitLab if you want. GitLab, mix it with Docker, mix it with something else, depending upon what you want to learn. Yeah, implement one of these pipelines yourselves. This is a good place to start. Then there are also, as I shared, so DevSec framework. That's DevSec hardening framework. This is for if you want to learn compliance as code or hardening, infrastructure hardening. This is one of the things you can do. Generally speaking, if you stick to this slide, these are the skill sets. If you have these, कुछ ज़्यादा होंगे, कुछ कम होंगे, that depends. Lekin yeah, if you only cover these, you will be like one out of everyone. So I still don't know Puppet and Chef. I've never worked with them. Ansible is mostly good enough for me. Jenkins, I've worked with a little bit. GitLab, a little bit more. Code pipeline, a lot. Git is usual. Python and Bash, Go. I still can't code in Go. Docker, Terraform, CloudFormation. So yeah, it's really depends on what you want to build and what you want to. Yes, just start, for example, with your own website. You have your website, okay, or start with, let's say, DVWA. So you pick up a vulnerable website, deploy TerraGoat or some vulnerable infrastructure. So vulnerable application on vulnerable infrastructure. Create 2 pipelines to deploy these, or 1, whatever, and then do all of these things as part of the pipeline. I think anyone who builds these 2 pipelines should be able to cover quite well DevSecOps.
Okay. All right. That is cool. So I don't see any questions. The last one is to just post these links in the Discord server. I will do that, and we'll also link these in the YouTube channel. And I think we're good to go. Thank you, Hassan Bhai, for joining. It's been 2 hours. Thank you very much for your time. I know you are busy, right? Like most of the time. But thank you very much for joining. And thank you, chat. And guys, I mean, whatever of you are left, right? So like we have, I think around 7 to 8 people. It was 30 in the start, but it's a good start, right? So thank you, everyone. Thank you for joining. Inshallah, see you again for the next Tech Talk. Allah Hafiz.
Thank you, guys. Allah Hafiz.